intelligence through computers, and that could be programmed things. But machine learning specifically is trained on data and is not necessarily programmed. And then deep learning creates complex neural networks to make connections within the data. So by combining machine learning and deep learning, and in relation to CrowdStrike, it creates an ability to analyze vast data sets and predict behavioral patterns within entities. And through doing this, human cognitive processes continuously learn from new data, so it's constantly evolving, which enhances cybersecurity and allows cybersecurity experts to respond to threats in real time. Continuing, this cycle diagram here represents refinement within these models and how their data is acquired, prepared, and tuned so that when the model is deployed, it's proactive. Now, these behavioral machine learning, what they do is they detect subtle anomalies in the data and any suspicious behaviors that traditional security measures, that would utilize humans might miss. And as I said before, they're constantly improving and evolving through learning. Even new threats, they implement that into the data set, and this allows it to respond to threats at an ever-changing rapid rate. And it quickly mitigates these threats because it can instantly read through data in large swaths of data, and as such, it can support strategic decision-making for cybersecurity professionals. So here, and this kind of represents CrowdStrike's model. So this training phase, represented in the purple, is the pre-processing phase. So this data is inputted and gathered, and it's trained on, so we can kind of establish a baseline of what should be the normal behavior of an entity. And so here, when there's an attack, you can see the entity's normal baselines are reflected upon. Here's the historical baseline, the peer baseline, and the partner baseline. And what those do is compare it to initial data and what's perceived as normal. So when there's a slight deviation in this entity, it identifies it as a cyber attack. And so that's how it utilizes advanced machine learning to mitigate these threats. And this is called user and entity behavior analytics. So that's CrowdStrike's model and how they reduce cyber attacks. And as you can see in this graph, it learns from past security incidents and patterns and maybe false positives. So here, you can see how the graph, it minimizes the false positives and increases the efficiency and accuracy within the threat detection. And that overall strengthens cybersecurity defenses, and that's how it adapts to new and emerging threats without compromising infrastructure.
So the history of behavioral machine learning is it started with the hot-fill network, which was just a computer which memorized the data and how it memorized to get from point A to point B. Then was the multi-main machine, which implemented hidden units, which helped with processing and it improved the data exponentially. Then it moved on to the LeNet network, which consisted of many layers and was able to recognize and classify data, and it was able to compute a variety of different problems with many different digits. And then finally what we have now is the ResNet, which addressed the vanishing ingredient issue. Here's a graphic of how it works. So it's able to skip past any layers that are unnecessary. And each layer, it goes through those mathematical processes, which were already explained. But that's how the ResNet works, and this is our newest, most current of behavioral machine learning.
So how does behavioral machine learning work? Behavioral machine learning is built on three main parts: data, algorithms, and models. Models are basically the entire thing, and they're built on the data being processed by the algorithm. So the way they work is, first you have the data from the problem statement that you're trying to find. Say you have fruits that you want to classify. You'll feed these into the algorithm, and then the algorithm will analyze the data and say you gave the data labels to begin with. So it'll bring that through and process that into like a collection that it'll use for future reference. And then eventually, if you want to feed it new data, you'll feed it data, and then it'll, based on patterns from the original data, it'll try and label it as accurately as possible to get an output and an accurate prediction. Alright, so what are the main different types of behavioral machine learning? We have supervised, unsupervised, and reinforcement learning. Supervised is when the data starts fully labeled, so you have all your data that you want to put in it, say the fruits, they're all labeled so you know exactly what they are going in. So the algorithm will probably be more accurate in terms of identifying future labels as well, because it knows what it is to begin with. So this works as classification. So when it gets that new data, it'll try to apply a label, maybe a percentage based on how confident it is that its label is correct. Next, we have regression, which is you'll take numerical data and it'll create a regression line, either linear or logarithmic. The logarithmic for more yes or no questions, and then the linear regression for if you want to make a prediction based on future values. For unsupervised, none of the data that you feed the algorithm is originally labeled. So this is more efficient if you have large amounts of data that you want to process all at once. And this is good with clustering, which is all the data is processed and it'll come up with similarities between the data, and it'll try and position it into similar categories to where, say, on the diagram, all the green ones are closer together, all the blue dots, they're closer together, and then all the orange dots are also clumped together. And then association rule learning, this is used mostly with online shopping. This will take frequently, say for online shopping, it'll take frequently purchased items together, and then it'll, based on whatever you purchase, it'll try and make recommendations based on what other people purchase as well. So it tries to come up with relationships between frequently grouped together items. And anomaly detection, which is mostly, probably the most important in terms of, say, UEBA. It'll try and analyze all the data, and then it'll come up with patterns to make a baseline for what is considered normal. And then based on new data that is imported, it'll analyze that data and it'll come up with whether or not it is say anomalous, which would be a percentage off of what would be considered normal. And then we have autoencoders, which are, it takes the data, tries to compress it down as much as possible to retain as much important information as possible. And then we have reinforcement learning, which for UEBA isn't that important, but it's basically just trial and error. So the system will try to get the correct answer or the correct result you want. And as it goes through, it'll get reward points for if it takes the right steps, and it might lose points if it takes the wrong steps.
So what is UABA? Jackson touched on it a little bit with how CrowdStrike uses it. Well, what is UABA? UABA is User Entity Behavioral Analytics, and it detects irregularities in the communication between a server and an endpoint to detect attacks. It creates a baseline profile, what you typically do on work or whatever you may do, and that's your baseline profile. Anything that's abnormal or anything weird, then they'll send it to a specialist at CrowdStrike, who then analyzes it, checks to see if it's an attack or whatnot, and then they counteract and prevent this attack. To do this, UAB applies mathematical models to view the analytics of user entities and behaviors. UABA can be used with SIEM, and SIEM is Security Information Event Management, which is the baseline code. Anything that's a blatant attack or anything like that is going to be detected by SIEM. However, SIEM does not have anything machine learning. So when UABA is paired with SIEM, it's able to detect and learn from these detections about what to look for when
some of the benefits of UEBA is that it is incredibly effective. In studies, it has had accuracy of detecting new threats that have never been deployed before and existing threats. It has had accuracy of detecting those and stopping those of upwards of 100%. Another thing that it's really good at is detecting new emerging threats. So as time goes on, more and more people are getting better with AI to create code. This code can be used in malicious ways, and UEBA is there to stop it. So what it has to do is it'll take similar threats from the past, and then it'll analyze the new threats, or the new potential threats, and it'll analyze how similar is the code, and is this malicious. So another thing that's good at detecting insider threats. So insider threats are also becoming more common as time goes on because people are getting better at writing code, and people are getting better at making software that can harm infrastructure of different companies. And this is specifically a threat with people who work at that company. And UEBA is really good at detecting those really quick to stop it. Another benefit, UEBA is much quicker than traditional methods of cybersecurity because it can analyze very large data sets very quickly. So some drawbacks, however, UEBA is very limited when dealing with privileged users. This is users that are potential admins on a network, users who worked on developing this cybersecurity, and it might struggle because people know how to bypass and work around some of those restrictions that UEBA has. And then UEBA also has difficulties detecting very long drawn-out attacks. This is because it detects how much of a difference it's making every day based on the attack. So how much data it might be taking, or how much data might be being trafficked to another site that might not be on the original network. And if it's very small amounts at a time over a very long period of time, it might not be able to detect it at all because the amount being trafficked to another site might be next to zero.
Questions?